Find the value of x in the following. We have a quartic here with each of the terms present, and we're going to have to use a pretty long method to fully factorize this for us to be able to solve. We'll have to use long division, potentially twice, to get this down into a fully factorized form. So let's get cracking with that. So we'll start by using the factor theorem to try to find some factors. I'll give this polynomial a name, I'll call it p of x. And I'm going to try substituting p of 1 to see if this is a factor. This gives me 1 minus 7 plus 1 plus 6. And indeed that is a factor because we have these two give minus 8 and all the positive ones add up to plus 8. So this is equal to 0. So that tells me therefore that x minus 1 is a factor. And remember, I get the minus 1 by just swapping the sign of that one. Since this is a factor, I can now do some long division. And I'm going to put that over here. So I have x minus 1, and then I'm putting my entire quartic under this division sign. So this is going to be quite a lot of steps to get through. Let's begin. So what is x multiplied by to give x to the power of 4? The answer is just x cubed. Subtracting that away, I'm subtracting away x cubed multiplied by x minus 1, which is x to the power of 4 minus x cubed. Now, minus x cubed minus x cubed is actually 0x cubed. So when I bring down my next numbers, I'm going to have to work on skipping a power because there's nothing there. So I'm going to skip a power and I'm going to work on the minus 7x squared. So what is x multiplied by to give minus 7x squared? Well, that's just minus 7x. And actually, I've got to make sure I'm lining these up. It's got to be over here because remember, we missed a power. So we have minus 7x. Now I'm multiplying minus 7x by x minus 1 to give minus 7x squared minus, so plus 7x. And subtract that all away. That gives me the 7x squareds cancelled, and then I have x minus 7x, which is minus 6x. And then bring the 6 down like that. Now finally, I have what is x multiplied by to give minus 6x, that is just minus 6. And then multiply minus 6 onto the bracket there, so minus 6x plus 6. And these will cancel off to give me 0. This is great. I've now got to a point where I can write out my polynomial p of x as one linear factor, and then I have a cubic factor. Alright, now unfortunately to factorize this even further, I will once again need to do long division. So these can get quite long. I'm going to isolate this part just to make it a bit easier to work with. I'm going to call it something else. Maybe we'll call it p and q of x equal to, and it's just the cubic part that we have left that we still need to factorize further. And once again, I need to find a factor that goes into this one. So let's try something else. Let's try q of minus 1. So q of minus 1 gives me minus 1 cubed, minus 7 times minus 1, minus 6. So that's minus 1 plus 7 minus 6, which is equal to 0. So therefore, x plus 1 is a factor of q in this case. Alright, since x plus 1 is a factor, I'm going to do my long division with x plus 1. And I'm going to put my entire q under here. And I have to make sure to include the space for the x squared term, which is missing. So I should still include a column even though there is no x squared term in my q. Okay, so we're all set up and ready to go. So let's start. How many times does x go into x cubed? That's x squared. Now multiply x squared onto that bracket. I get x cubed. X squared times 1 is x squared. Subtracting that away, these two cancel off, and I'm left with 0x squared minus x squared, which gives me minus x squared. Now bring these two down, I get minus 7x and minus 6. And I'm ready for my next round. What is x multiplied by to give negative x squared? that is negative x. Now multiply negative x onto x plus 1, I get negative x squared, and negative x times 1 is just negative x. Adding these up, these cancel off, and then I have minus 7x minus x, which gives me minus 7x plus x, which is minus 6x. And I can bring that 6 down as well. Finally, what is x multiplied by to give negative 6x? That is just minus 6. And then I can subtract away minus 6 times x, which is minus 6x, and minus 6 times 1, which is minus 6. Those all subtract off, giving me 0, so that's an excellent sign. And now I can say that q, when it's fully factorized, is equal to x plus 1, x squared minus x minus 6. And actually we have another factorization step we can continue with, but I'll do that on the next page. Now, I have factorized q of x, which was the cubic component of p of x. I've factorized that down to get a linear term and a quadratic term. My last step is to factorize this quadratic term to get two linear terms if I can, which I'll try by using the cross method. So my x's go on the left, and 2 factors of 6 go on the right. There has to be a positive and a negative since it needs to be negative 6 overall. And I can see that the middle term is negative, so a bigger number will be negative. So let's try 3 and 2 like this. And we can multiply along the diagonals to check. So x times minus 3 is minus 3x, and x times 2 is plus 2x. So I'm left with negative x, which matches with the middle term, so my cross is correct. Now I can just write those out. I get x plus 1. And then reading across, I have x plus 2 and x minus 3. Fantastic. Now q of x is fully factorized. We have 3 linear terms. And remember, that was from the component of p of x that was a cubic. Now we can go back and rewrite what p of x is fully by replacing our cubic here with the fully factorized version that we've found. First, p of x has the x minus 1 term, and then we have the cubic. So instead of the cubic, I'm putting x plus 1, x plus 2, and x minus 3. And that's p of x, which is equal to this. Now, the question is actually to find x, and the question was p of x equals to 0. So we're going to say p of x equal to 0, and if we put 0 there, we can use the null factor law, which I'll just write this out one more time, and then we'll use the null factor law to solve this. Hopefully now it should be pretty straightforward to use the null factor law. All I do is let each of the brackets equal to 0, so I end up with x equal to minus 1 equal to 0, so x equals positive 1, x equal to minus 1, x equal to minus 2, and x equal to positive 3. These are my 4 solutions for x. Because it's a quartic, you can have up to 4 solutions. And just as a recap, what we had to work through was quite a lot of steps. So we started by factorizing this. First, we had to find a factor, which we did with the factor theorem, and after doing one round of long division, we ended up with a linear term and a cubic term. We then called that cubic term q and went through the whole process of using the factor theorem to find one more factor, and then using long division again to find, now this time it was a linear term and a quadratic term. Once we had our linear term and our quadratic term in this step, we used a quadratic factorization technique to get the quadratic fully factorized into 2 linear terms. So our cubic ended up being 3 brackets, and then when we put it back into our quartic, we had 4 brackets, and once we had those 4 brackets, we can use the null factor law to find our 4 solutions. So it's a pretty long process for quartics. Hopefully this question doesn't come up too often. It's just a good exercise to try because it's actually extendable to any power. It doesn't have to be a quartic. You could have an x to the power of 7 here, and you would just need to do long division maybe 3 or 4 times before you can get it fully factorized down. So it's a good technique to be aware of, but yeah, it probably doesn't come up too much in tests because it's quite time consuming.